Welcome! Today we're going to break down a geometry problem involving a circle, a tangent, and a secant. The problem states, from a point A, not lying on the circle, a tangent and a secant are drawn. The distance from point A to the point of tangency, which we'll call B, is 16. The distance from point A to the farthest intersection point of the secant with the circle, which we'll call C, is 32. We need to find the radius of the circle if the secant is located at a distance of 5 from the circle's center. Our goal is to find the radius, which is the segment OC. Looking at the diagram, we can see that the radius OC is the hypotenuse of a right-angled triangle, OEC. We are given the length of one leg of this triangle, OE, which is 5. To use the Pythagorean theorem, we need the length of the other leg, CE. We don't know the length of CE directly. However, we know that CE is half the length of the chord CD, because the line from the center, OE, is perpendicular to the chord. So, to find CE, we first need to find the length of the entire chord CD. The length of chord CD is the total length of the secant from point A, which is AC, minus the length of the external part of the secant, AD. This means our first step will be to find the length of segment AD using the tangent-secant theorem. Once we have AD, we can calculate CD, then find CE. With CE and the given OE, we can use the Pythagorean theorem in triangle OEC to find our final answer, the radius OC. So, to execute our plan, we will first calculate the length of segment AD. We do this using the tangent-secant theorem, which states that the square of the tangent segment from the point to the circle is equal to the product of the entire secant segment and its external part. In our case, this is AB squared equals AC multiplied by AD. Plugging in the known values, we have 16 squared equals 32 multiplied by AD. This gives us 256 equals 32 times AD. Dividing 256 by 32, we find that the length of segment AD is 8. Now that we have the length of AD, our next step is to calculate the length of segment CE. To do this, we first need the length of the entire chord, CD. We can find this by subtracting the external part, AD, from the total secant length, AC. So CD equals 32 minus 8, which is 24. Because the line from the center, OE, is perpendicular to the chord, CD, it bisects the chord. This means that CE is exactly half the length of the chord, CD. Therefore, CE is 24 divided by 2, which equals 12. With the lengths of both legs of the right triangle OEC now known, we can calculate the radius of the circle, segment CO. We will use the Pythagorean theorem, which states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So, CO squared equals OE squared plus CE squared. Substituting our values, we get CO squared equals 25 plus 144. Adding these together, we find that CO squared equals 169. To find CO, we take the square root of 169. The square root of 169 is 13. The radius of the circle is 13. If you have found other ways to solve this problem or noticed any errors, please leave a comment. Also, let us know if you'd like to see a proof of the tangent-secant theorem. Subscribe to the channel so you don't miss new interesting problems. Until next time.